As promised, we're going to look at some trick geometry, and this time around we're working with proportionality in triangles and in figures. Okay, so let's have a look here. They've given us the parallelogram A, B, C, D. Okay, now I've filled in that these are parallel to one another. Just bear in mind that the opposite sides are also equal to each other, and that the diagonals of this parallelogram, because it is a parallelogram, these diagonals will bisect one another at the point M. Then they said that we have a line segment EF that is drawn parallel to BD with E on AC and F on AD. Okay, so these two lines here, this diagonal is parallel to that line. And then lastly, they tell us that AF to FD is 4 to 3. Now, folks, let me make this a little bit smaller so that we can refer to our diagram all the time. There we go. Okay, let me make it a tad bit bigger. There we go. Now we are going to use that information and we're going to fill in a little bit of our own information. Remember, if you have a triangle and there's a line that runs parallel to one of the sides of the triangle, this line will divide those two sides proportionally. Okay, so in other words, if I look at triangle AMD, EF is parallel to MD, and they've given us that as 4 to 3. So we transfer that to this side, but folks, you introduce a variable. You say FP and 3P. You could have said FM, 3M. The purpose of that is to show you're taking the proportion 4 to 3 and you're turning it into a length. And it's not the length 4 and the length 3. That's the purpose of the little p over there. But now look at what just happened here. Because M divides this diagonal, this length is 7p together. So this length here will also be 7p. Okay, now let's move into triangle EFC. In triangle EFC, this line MG is parallel to EF. And we've already got 3p to 7p. So we're going to say this here is, let's make it 3m to 7m for now. Why is that the case, folks? Because there's a line that runs from one side of the triangle parallel to the third side to the other side of the triangle. So in other words, we've got this. We've got a triangle in both cases with a line that runs parallel to one of the sides. The result is that it divides the other two sides proportionally. We could have also said something else. We could have said, look at this, that this length over that length is equal to the bigger length over that bigger length over there. Why is that so, folks? Because these two triangles are similar. Why are they similar? Let's have a look. This angle is equal to that angle because these lines are parallel and the side is the transversal. The same for those two angles. That angle is shared, so this little triangle is similar to the bigger one. So there's a lot we can do here. Okay, let's see what they ask us. The first question is saying, find a ratio for, what is it, EM over AM. Now let's have a look. How did we find what here? I'm just going to remove my last diagram here because I'm going to need that space. There we go. Okay, so EM was 3p. And AM is 4p plus 3p. But remember, that happened because of the initial ratio given. So we're going to start by saying EM, or let's start by acknowledging the parallel lines. In these two triangles, okay, so in this triangle given to us is that EF is indeed parallel to MD. That was given information. Based on those parallels, AF over FD, or let's choose the sides we want. We want EM, this one and the whole one. So let's say FD rather. Let's go EM corresponds to FD. Where's my pen now? So FD over there, over the whole one, which is AD, is nothing other than 3 over 7. But it's equal to EM over AM. And the reason for that is the sides are in proportion. And both of those will then be equal to 3 over 7. So we have our first question answered, that EM over AM is indeed 3 over 7. The second question that they ask us to show is that CM, or find the value, the ratio CM over ME. CM over ME. There's CM, there's ME. Now we've already got that CM is 7p. How did it become 7p? Well, it was the diagonal that was bisected at M. So we need to start our argument there. So we start off, we say M is the midpoint of diagonal AC. Why? The diagonals of a parallelogram, this is shorthand for parallelogram, bisect one another. So therefore, MC in this case will be 7p units long. And we've got EM already. EM is equal to 3p. That was what we discovered above here. Okay, so all we need to conclude then is that CM over the ME is nothing other than 7p over 3p. And folks, you can see here the p's take care of themselves, and your final answer is 7 over 3. Now, I'm showing you this so that I can give you a tool to use effectively when you work with ratios and proportions in a geometry problem in the exam. Okay, let's look at what the third part is. I'm going to put the question on the screen and then we'll go back to the diagram. The question says we want the area of triangle FDC divided by the area of triangle BDC. So FDC and BDC. Now I'm going to use another color here. Where's FDC? There's FDC. Yeah, I'm trying to draw straight lines here. There we go, they're quite straight. So FDC and BDC. Now BDC is this one here, BDC. Now folks, those two triangles share one thing. They share the side DC. Okay, so we've got to dig a little bit deeper here. What do the diagonals of a parallelogram do to the area of the parallelogram, seeing that we want the areas? Okay, let's have a look. The area of BDC is going to be the same as the area of ADB. Why is that so? Well, they have the same height because they lie between the same parallel lines and their bases are equal in length. Now the same happens with this one. That triangle ACB and triangle ADC. They are all equal to each other because they share the same base and the same height. So if I want to work with the area of FDC, remember your diagram. This is what our diagram looks like now. I'm just going to redraw it over here. There's the triangle. The FDC is or EDC is the smaller one here with the 3, and the other one has the 4. So DFC, this is point C, and ABCD, this is F, and that will be the point A over here. Now, folks, can you see they share the same baseline and they have the same height? Okay, so the triangle BDC, let me just see, where's my BDC? BDC, the area is equal to. So we can start the area of triangle BDC is identical to the area of triangle. Now look at this. This is BDC is the same as ADC. Same base, same height. ADC. Okay, so those two areas are indeed the same. ADC and BDC. So we can now, and the reason is same baseline, same height, or same apex, meaning they share that point there. The base is in a line, and therefore the height for both of these will be the same. So all we need to do now is we need to go and answer the final question. The area of triangle FDC, remember, if we have this situation, the area of the big one over the area of the smaller one is the length of that base divided by the length of the smaller base. Because they have the same baseline and the same apex. So the area of triangle BDC will then be FDC is the smaller one. So this is 3 over 3 plus 4, which is indeed 7. Okay, folks, you have to, there's a beautiful word in Afrikaans. It says you have to hou kop. Keep your spanners and everything together. You have to absolutely work slowly when you work across a figure with these type of areas that are the same. Look at what my diagram looks like. So I suggest that in an exam paper, you take yourself in some very fine colored pens and also some highlighters, at least 2 or 3 colors, so you can highlight the triangles that are on your diagram.